Hello, everyone. Good evening, and welcome to another insightful episode of the Cohort 2 Onboarding webinar. Before we proceed, kindly send a reminder to your colleagues on your various groups that we are live. My name is Victoria Undu, and I will be moderating the session for today. Today, we'll be looking at two exciting fields. If you've ever wondered what cloud computing and DevOps is about, well, today we have two experts with us in the studio who will be giving an overview of what the courses are about, the opportunities available for you, and they would also be answering questions you might have regarding these courses. So get ready, get your pen, your pad, and also get ready to drop questions in the comments so that our experts would answer them. All right, so if you're ready, please drop in the comments that you're ready and good to go so we can start properly. All right, so right about now, I will be introducing our guests for today. We have two amazing experts who will be taking on the subject for today. Tobena Wokike, and he is a seasoned software developer with over a decade of experience in the field, and as a senior cloud engineer and consultant at Serverless Guru LLC USA. He navigates the complex realm of cloud technologies while working remotely from Nigeria. He also currently serves as the CTO at a prominent Nigerian fintech, iRecharge, and he holds a first-class honors BSc in computer science and MSc in software development with a distinction from Coventry University, UK. And his expertise is further underscored by his numerous certificates as an AWS DevOps professional and lots more. He has several client portfolio that includes top-tier companies like Air Canada, MTN, Ibadan Electric, and the Central Bank of Nigeria. Today, Tobena is going to be sharing more on DevOps. Hello, Tobena. Good evening.
Hi, Victoria. Hi, everyone. Pleased to meet you. It's an honor to be here today. Thank you.
Great. Welcome. Yes, thank you so much. And so our second expert for today is going to be talking on cloud computing. He'll be sharing more about what it's about and the various opportunities you can access in this field. He is Taiwo Amayo. He is an application engineer at the Stanbic IBTC, a cloud engineer with expertise in building, automating, and optimizing mission-critical installations in the cloud. He's a skilled IT professional with over 5 years experience in application support and cloud engineering. He has managed several applications in the past, like the token management system, CRM, interactive voice response, and a whole lot more. And so today, he's also going to be taking us on cloud computing. Please, everyone, join me, make welcome our two guests. Just put something in the comment section, an emoji, to show that you're ready to learn. And do not forget to also drop your questions in the comments. So right about now, Tobena will go first. You have 15 minutes, just share. And then Taiwo will come up next, and then we'll take questions. Thank you.
All right, then let's go. One moment while I pull up my slides.
Okay.
So please let me know when you can see it. I've given you guys expo now by being at the end. But yeah, can you see my slides?
Yes, very clear.
Okay, so I'll go ahead and play it. I hope this doesn't break anything. Oh, it says it's paused. Okay, so let's do this again. Sorry. Let's do this again. Okay, there we go. So is it fine now?
Yes.
Okay, so I noticed that when I share the full screen, then it pauses it. So I'll just leave it like this. I hope it's not distracting, but let's just go. So like Victoria had said, I'm Tobena Wokike. I'll be talking about introduction to DevOps, just to, give you guys an idea of what DevOps is, the opportunities that are, existent in the ecosystem, and, just water your palate, as they say. So I won't dwell too much on this slide because she has already done a fantastic job at, hyping me up and saying the things I do. But here I'm also CEO at my consulting company, T-Logics, where we just do a lot of consulting. So for companies abroad and in Nigeria. And I'm a DevOps professional. So I've been doing this for a while now. I've, seen the good, the bad, and the ugly sides of DevOps. And today I'm here to tell you, share my experience as well as, give you some information about DevOps to accelerate your journey. So we'll just start right away because I have about 15 minutes. So what is DevOps? That's where we're starting from today. So DevOps is basically dev and ops. So what that means is it's an approach to software development that enhances collaboration between the development team and the operations team. The development team are the guys that build the applications, and the operation team are the guys that monitor, the guys that ensure that, everything is going as planned. So DevOps is a practice that enables that to ensure that there's better communication and that the dev and the ops team are working seamlessly. Now, this is an oversimplified explanation. As we go through the slides, we'll really understand what it takes to be a DevOps engineer. It also increases the organization's ability to deliver applications at high velocity. So simply put, it just enables you to, as an organization, to be able to deliver your applications more quickly, deliver better applications because there's better communication. And then I will dive right into the symbol that you can see on the screen. So the infinity symbol. So what that signifies is that it's a process that is always, it's a never-ending cycle. It's always going on. So on the dev side, the planning, the coding, the building of your application, the testing of the application is done on the dev side. And then on the ops side, we have, releasing the application, deploying it, making sure that it's operational, and then monitoring the application to ensure that it's working. And then when changes need to be made, it goes through that cycle again. We'll move forward next to the key principles in DevOps. We've already talked about collaboration between the dev and the ops team. But another principle that's very key in DevOps is automation. So what that means is that these processes that need to be put in place such that the dev team and the ops team are working seamlessly. They need to be automated. I'll talk more about that in the slides that follow, but simply put, there are processes that need to be in place to ensure that, the dev team and the ops team are functioning at, optimal capacity. And you need to ensure that those processes are as automated as possible so that you don't have to manually go into the system and start tweaking things. There's also the principle of continuous integration, which has more to do with the dev side of things. And what that means is that as your developers are writing code, the DevOps engineer enables them by ensuring that the code that they are writing is continuously integrated. And what that means is that as they write code, they push it up to a central repository, it gets built, it gets tested. So that's what one of the principles of DevOps. The other principle, the final one here, is continuous deployment. And that has to do more with the ops side of things, where that code that has been written, built and tested has to now be released. It has to be deployed. It has to be monitored. So that is more around the, continuous deployment side of things. And these are the principles of DevOps. We'll move forward to the next slide, which is some of the benefits. Now, having said all the things that I have already said, one of the major benefits of DevOps is that it gives you a faster time to market. Because of the fact that most of your processes are automated, the IT team is collaborating efficiently and you're planning things out, in a more efficient manner. You're able to get your products to market a lot faster. Automation also enables that. It also gives you increased reliability on your systems. You're integrating processes that allow you to be able to automatically do things like, build your application and test. So you've gotten past the issue of, sometimes when products are released, you find out that the products are buggy. So you want to click on a button, it's not responding. You want to send money to someone. For those of us in fintech, it's not going through. So you can avoid things like that with DevOps because you are integrating your tests into the process such that if your tests don't pass, you're not able to release anything. It also improves collaboration. We've already mentioned that a few times, or I have already said that a few times. And then it gives you greater efficiency in building things, which is very related to the reliability side of things. It reduces manual processes. So because of that, you're now able to be more efficient. You're able to build things with more speed, with more efficiency. You're more sure of what you're building and how it's going to function when it goes out to the public. Now, there are some tools and technologies that a DevOps engineer needs to be aware of. I know this is an introduction, so if you're looking at my screen right now, please don't get overwhelmed. All these things are going to be covered when you start your course, but then I'm just going to highlight them. You don't need to know all of them. Sometimes it's a pick and choose kind of setup, where you need to know maybe one of each section and you're able to build. So don't get overwhelmed, please. Just follow me as we go. So the first one is version control systems, and the most popular of them is what we call Git. It's basically, in layman's terms, it is basically when your developers write the code and they check in the code, they say, okay, I've written my code and I've pushed it up. Git is a technology that enables you to version that code, so to track the changes that have been made to the code, such that if I push up code today and tomorrow Taiwo pushes up code tomorrow and I want to go back to the code that I wrote, I can always go back and see what I wrote yesterday and see if there was a problem with it. Then we have continuous integration and continuous deployment tools. I've already touched on continuous integration and deployment, which is has to do with development and the operation side of things. So we have tools like Jenkins that enable you to automate that process. There's also Travis CI, the Circle CI, but what they do is they enable you to automate the process of continuous integration and continuous deployment. Then we have tools that enable configuration management. As you're building out these applications, for those of us that are conversant with building out software, there are certain configurations you need to have, whether it's your keys, whether it's your infrastructure. There's some configuration that you need to have. And in order to automate that process of deploying your software, you need to store those configuration details. So tools like Ansible, Puppet, and Chef enable you to do that. Then there's this concept called containerization. Containerization is simply put, packaging your applications in such a manner that they can be run on any system. Whether the person is using Windows or Mac or Linux, they're able to run the application that you've built and not be worried that it's working on Mac, and it's not working on Windows, or it's working on Windows and it's not working on Linux. So it enables you to be able to run your applications on any operating system. There's a lot of technicality around that, but then simply put, tools like Docker and Kubernetes enable you to do that. And then there's the final side of things, which is monitoring and logging. If you remember the diagram that I showed, there was a monitoring section, which is very, very key on the operational side of things. So tools like Prometheus, Grafana, and the Elk Stack enable you to monitor your application while it's running. You're able to see, alerts. You're able to raise alerts, raise alarms. You're able to see how your application is performing and react to them as well. Logging is simply you're logging information from your application so that you're able to see or adequately monitor your application. So these are some of the tools that a DevOps engineer needs to know about. And I'll move forward now to some of the best practices. As a DevOps engineer, there are some of the things that you need to know so that you ensure that you're building things or you're building out your DevOps career, or you're going through your DevOps career in the best possible way. And one of them is infrastructure as code. So rather than setting up all these, tools when you're building out software, maybe you're setting up your servers, you're setting up the databases, you're setting up a whole bunch of stuff that you need to set up to run an application, then you would have to imbibe the practice of using infrastructure as code. And what that means is that rather than setting these things up, maybe going on platforms like AWS or Azure and going to, the console and clicking on things. You want to set up a server, you go and click. You want to set up a database, you go and click. It's not maintainable. It defeats the purpose of DevOps. So that's where infrastructure as code comes in, where you're defining your infrastructure as code so that you can always update that infrastructure as code, file, or however you choose to go about it. Whenever you update it, your infrastructure is updated. If your infrastructure goes down and you want to deploy a fresh new instance of your, infrastructure, you can just run your infrastructure as code and it deploys everything that you need. There's also the best practice of using a microservices architecture. Now, microservices architecture is basically if you have a big body of work, which is your software, you're breaking it down into smaller modules that are more maintainable. They are easier to, manage, and you have less, single point of failure, because the worst thing that can happen to you is maybe you're building a payment system out and then your notification service is down and your entire infrastructure is down as a result because your SMS provider is not working. So things like that, when you imbibe the practice of microservices architecture, you're not going to have that kind of problem because your notification service is going to be its own thing. There's going to be a payment service. So things can work independently and don't necessarily have to depend on each other. And then there's site reliability engineering, which simply put is putting practices in place to ensure that your application is resilient. And when I say resilient, it means that your application doesn't go down. You have the highest uptime possible. So putting things in place, and that's where, things like monitoring and logging come in. Things like setting up your alarms, your alerts, so that you're able to react to things, before you're proactive, rather than reactive. I think that's what I was looking for. So those are some of the best practices. Now we'll be jumping more into, some stats around DevOps. So DevOps adoption is rising and it continues to rise. Now, there was a report by Puppet in 2021 that showed that, DevOps adoption increased at companies from 2020 to 2021 by 2%. And this is like an old stat. Now, I don't know any DevOps, any proper company or any serious company or even startups that don't imbibe the practice of DevOps, because it is very critical to how your systems function. I had Victoria say that Ty will manage his mission critical applications, and I'm sure he will also say that, in order for you to be able to manage mission critical applications, you need to have DevOps. You need to adopt DevOps. So the adoption continues to grow. Now, DevOps engineer was among the top emerging jobs, and there was a 32% increase year on year in the United States. And this was done by, we all know LinkedIn. There was a report by them in 2021 that corroborated this. And then the part that I know is very exciting to a lot of us is the pay side of things, because, I know we all like to do things for passion, but we all also want to get paid when we build or when we work. So the average salary of a DevOps engineer is 124K. And I can tell you that's very true because I work remotely right now for a company called Serverless Guru. I'm not going to tell you my pay, but I can tell you that this is very, very true. DevOps is in high demand and people are willing to pay as much as $124,000. You can work from Nigeria here and earn that. And that's what 3MTT is trying to do, to scale us up so that we're able to get these, very lucrative jobs. And then now we've talked about the stats, we've talked about how much it takes to get or how much a DevOps engineer gets on a yearly basis. Well, how do you start your DevOps journey? The first thing is to learn the basics. So there are some tools that I projected in my previous slides. Like I said, you don't need to know all of them, but you need to learn the basics. You need to be able to understand DevOps and have, theoretical knowledge, try your hands out at things. And then the next thing would be to gain hands-on experience. And what that means is you would have to get an internship, do a side project. There are multiple ways to get hands-on experience. You can even follow a course online, so long as it's current and get hands-on experience. You can also join communities and then have a mindset of continuous learning. I'm going to end my presentation by saying that by projecting a quote from one of my favorite authors. And it says, ultimately, it's your commitment to the process that will determine your progress. Simply put, show up every day, ensure that you're learning every day, ensure that you're growing every day. And you will definitely be able to become a DevOps engineer and get some fulfillment and good pay from it. So that's where I'm going to end. I think I've slightly overshot my time. Thank you so much for listening. And I'll entertain your questions later. Thank you.
Thank you so much, Tobina, for doing justice to this subject. And I trust that our learners have gotten clarity needed for their journey. We will take questions shortly after Taiwo's session. Taiwo, over to you. Thank you.
All right. Let's give some slides. Right, to remember. Hi, good evening, everyone. Thank you so much for this opportunity. And Tobina, your session was fantastic. I really learned a lot from it. Thank you. Hi, everyone. I'll be sharing my screen shortly. And my session will be brief as well. Okay, so Victoria has given a brief introduction about me. I currently work with Stanbic IBTC as an application engineer, but I specialize in the cloud arena. And I usually see Tobina's activities on LinkedIn as well. It's very active on LinkedIn. So thank you for the value you're adding to the community. Okay, so I'll start what cloud computing means. And basically, I will just give a very layman explanation of cloud computing because, of course, I don't want to give a textbook definition. I want to give something that you can go away with when you leave the session. So basically, it's just providing computing services on the internet. That's the layman understanding of cloud computing. So basically, for instance, you have your storage on your laptop and you connect to the internet with your laptop. So those are local computing services. So when computing services are provided for you over the internet, like network, storage, servers, and other things, when they are provided over the internet, they are called cloud computing. So that's just the layman definition of cloud computing when computing services are delivered over the internet. And there are various services and models. So almost every organization is adopting cloud computing. I can say over 80% of big corporations and enterprises are adopting cloud computing. And the various reasons why they are doing that is one of the reasons is to save cost. So it's very difficult, cost effectiveness. It's very difficult for you to have a data center. The cost that comes with is called capex. That's capital expenditure. That is the cost that comes with you managing a physical data center. You can imagine setting up a data center. You have to make provision to manage the lightning data center, to manage the heat, and ventilation of the data center, and then so a lot of cost comes with you managing a data center. So what cloud computing comes to do is to manage that cost for you. So you have third parties like Amazon. So Amazon has the Amazon Web Services, Microsoft has the Azure, Google has a Google Cloud platform, Alibaba. There are many cloud providers. So you imagine these third party providers paying for these services for you. It reduces the cost. So these cloud providers have the capacity, they are rich enough to pay for all these services. And then you have computing resource management. So managing these resources also takes a level of expertise, takes a level of experience to manage all these computing resources, managing your network, managing your servers, managing your storage. It takes a lot of experience and expertise. So that's another reason why we are making use of cloud computing. And then we have availability of infrastructure, reliability, and fault tolerance. So you imagine you managing a data center, and inside the data center you have many servers, and it's on these servers that you have your applications and your other infrastructures. So for example, now we have Facebook, for instance. Facebook has its own data center, right? And inside the data center there are various servers, physical servers, where we have Facebook running. So you have billions of people connecting to Facebook, and for Facebook to be able to run today, it means the computing power that holds Facebook needs to be astronomical. So and you can see that most times Facebook is available, most times Instagram is available, most times Google is available. That is because there is the required capability and expertise to manage those infrastructure to ensure they are always up and running. So that's another reason why we are employing cloud computing. And probably in your organization, you may want to deploy cloud computing, and there are various models to deploy cloud computing. Public cloud. What do we mean by public cloud? Public cloud is basically a third party providing computing service for you over the internet. So it's a third party that is doing it on behalf of your organization or yourself. So for example, now you reaching out to Amazon through the Amazon Web Service, that's a public cloud. You reaching out to Microsoft through their Microsoft Azure, that's a public cloud. You reaching out to Google through their Google Cloud platform, that's a public cloud. So it's a third-party cloud provider that is making provision for the cloud service for you. That is what we call public cloud. I beg your pardon. Then we have your private cloud. It is your organization that is making provision for that computing resource. They have their own data center. They have their own on-premise data center where they provide for these cloud computing services. So that is what we call private cloud. So for example, we have company ABC Limited, and company ABC Limited has their own data center where they have their physical servers and other things. That is a private cloud. And then we have the third deployment model, which is hybrid. Hybrid, when you say hybrid is just a combination of the two, both private and public. So there are some organizations that employ the hybrid model, where they reach out to third party like Amazon or Azure, and also have their own data center. So because, for instance, now in banks, I work in a bank, and there are certain data that you cannot host in the cloud because of CBN's regulatory policies. You can't, and that is why most banks adopt the hybrid model. So there's some data that has to stay in-house, their own private cloud environment, and there's some data that are allowed to stay in the public domain. So that is what we call the hybrid cloud model. Then we have service models. So I don't want us to mix it up. The one I just spoke about now is deployment model. And then we have service model. Service model is basically how you implement some of these services in your own space when you're using it. So infrastructure as a service, for example, infrastructure as a service is just a service model whereby the third party provider deploys these computing resources. When I say computing resources, your network, your storage, your servers, and other things. they deploy it over the internet. So that is what infrastructure as a service is. They deploy all these computing resources on the internet so that you can now go to them, pay for what you want to use. It's called a pay-as-you-go model. So you just go to them, okay, I need a storage of 1 terabyte, pay for it, and then you use it. So that is what we call infrastructure as a service. And then we have platform as a service. So example of infrastructure as a service, we have your Azure, we have your AWS, we have your GCP, and then we have platform as a service. So platform as a service, what they do is just like the name implies, platform means providing platform over the internet. So this is much more usually applicable to developers. So, developers, you can imagine you writing a solution to solve a problem and trying to also host that solution or deploy it to an infrastructure and still managing the infrastructure. I know Ubina explained the concept of DevOps the last time, the presentation before mine, as a combination of both development and operations. So the development part, you imagine you combining these two activities. You can imagine the stress that you have to go through, combining both development and also now deploying that application to an infrastructure, managing the infrastructure, monitoring the infrastructure, and ensuring that it's available. It's very tedious. So what platform as a service does is, so a third party, what they do is they provide that platform for you over the internet. And then the only thing you just bother yourself about is to write the code, push the code, and their platform sets fires your solution or spins your solution. An example is AWS Elastic Beanstalk. AWS Elastic Beanstalk is just a service. What you just do is just as a developer, what you do is just write your application or your code in whatever language, .NET, Java, whatever language. Pick your code and push it to AWS Elastic Beanstalk. What AWS Elastic Beanstalk does is that it just whatever underlying infrastructure that your application needs to run with, it spins it and your application works. You don't need to be saying you want to be spinning EC2 instance. You don't need to say you want to be spinning RDS for a database. You don't need to be spinning from Lambda or whatever. Just push your code there and it fires your application and it works. The same thing is also Google App Engine is also an equivalent of AWS Elastic Beanstalk, but Google App Engine is of course for Google. And then we have software as a service. Software as a service is basically making just provisioning a software on the internet. What you just do, you just launch that software on the internet, and what you just do is to supply your data. An example is your Slack, your Salesforce, your Dropbox. You have even your Google Drive is also SAP and some other ones. They are examples of software as a service. You are not writing any code. The software is readily available for you to consume on the internet. So that's basically these are basically the service models that we have. And then let me quickly move to the cloud specialties. Tobina was giving us some statistics on DevOps, and it's also applicable to cloud also. So almost virtually every organization, every serious organization in our world today is adopting cloud computing. So if you're an IT, if you're a serious IT person, there is no how you don't need to learn about cloud. And there are many specialties in cloud, because generally people just say cloud. And the truth is you cannot know everything in cloud. You cannot know everything in cloud. You have to know, you have to have an area that you want to specialize in or that interests you. For example, in my own case, I'm interested in DevOps and security. And I'm sure we must have been hearing about DevSecOps. DevSecOps is just the way we have DevOps as a combination of development and operation. We also have DevSecOps as a combination of DevOps and security. It's just you putting a layer of security on your DevOps. That's all. So there are many specialties. There's cloud administrator, a cloud administrator. And if you want to be a cloud administrator, there is a track for you to follow. So there are certain exams like your foundational exam where you do your let me use AWS track as an example. So you have your AWS cloud practitioner exam. And what I would advise is, as a starter, it's very good. Don't jump tracks, right? So for some people, they will not start from cloud practitioner, they start from maybe solution architect as you fit, and they move up. That was, even though I have many years of experience in IT, I studied with the cloud practitioner track, so that you will be able to understand the basics and the fundamentals. So it is in the cloud practitioner track that they will teach you what the service models, the deployment model, and other things are, and the function of the services that you have with the third party cloud provider. So you can decide to be a cloud administrator and manage services in the cloud. You can decide to be a cloud developer. So what is the difference between an ordinary developer and a cloud developer? So a cloud developer has the ability to utilize cloud services to their advantage. So it's not just on-prem. You get to be able to use the services that third-party cloud providers have provided for you and use it to make your work much more efficient. Then we have DevOps engineer, which Tabina has spoken about earlier on. You can decide to be a cloud network engineer, you can decide to be a cloud security engineer. So these specialties have been existing. It's just that before now, it's just that most of these specialties are applicable to on-prem. On-prem means local structure. But now, you being a cloud security engineer means that you can secure services in the cloud. You being a cloud network engineer means that you understand the networking aspect of the cloud. So that is just about cloud specialty. So as you start your cloud journey, you should start thinking of where you would want to fit in to one of the specialty and where what interests you per se. Then let's move to how long does it take to become a cloud engineer? I started my cloud engineering journey over 3 years ago, and I wouldn't say there is a fixed duration of how long it takes to be a cloud engineer. It depends on how fast you can learn, and it depends how much you dedicate to learning. So number of hours dedicated in a day or in a week and so on. So well, if I was to say that maybe at least you've been okay on the cloud journey, in a year or less, you should be able to should be okay if you are following the right track and if you are giving it all it takes every day. I think in a year or less, you should be fine as a cloud engineer. And then also the kind of resources you also use as a cloud engineer also matters. For example, if you want to, one of the things I started with Azure when I started learning, but I didn't find Azure very interesting or easy for me, so I moved to AWS. I had a friend, his name is Vincent. He's a manager of PwC in UK now. He started with AWS. I was working with Azure. I didn't understand Azure well, so he introduced AWS to me and I started with AWS. So I've learned AWS to an extent that I can switch to Azure. I can switch to an understanding of the cloud providers. So that is so it's just like programming too. As a developer, if you can understand the language, you understand the syntax and semantics, you can understand the language. I think I've exhausted my time. So thank you once again for inviting me to this important session. I'm also happy to meet my guy here too. Thank you for your session as well. I'll be taking any other questions.
Okay. So much. Thank you, Taiwo, for sharing such a very enlightening session as well. Thank you, Tobina. So right about now, we'll just be taking questions from the comment section. We have quite some questions here, and I will just be reading out for you. So Tobina, the first question to you. So can one say cloud engineering is the base foundation for DevOps? I am currently enrolled as a cloud computing student, but with a hope to transition to a more superset. So is it related?
Yes. You said it really well. You need to have foundational knowledge or knowledge about cloud computing to be a good DevOps engineer. I've met people that didn't really have cloud knowledge, but it took them time. So having that knowledge of cloud computing would definitely accelerate your growth as a DevOps engineer. I was already a cloud engineer, a cloud developer before I moved into DevOps.
Okay, amazing. So starting from that question, Taiwo, I'd like to ask you, based off the question in the comment section, somebody is saying, do I need to know coding before going into cloud computing?
You don't need to know coding at all. You don't need to know coding before you start cloud computing. And because just like I explained, there are many specialties in cloud computing. But for some specialties like DevOps, cloud developer, and I think DevSecOps, you should have basic coding understanding. Maybe you can pick languages like Python or Go language. So, but for you to start cloud computing, you don't need to know coding. Thank you.
Amazing. Okay, so Taiwo, before I ask you the next question, please stop sharing your screen so that we can proceed in questions. Thank you. So Taiwo, over to you too. Can one generate data through cloud? And that's the question that's being asked. Can one generate data through cloud?
All right. So when it comes to cloud, you can generate data through cloud, but it depends on the context
Okay.
of how you are trying to generate the data. So, but fundamentally, you don't generate data through cloud. So, in a case where, for example, you are building an API, for instance, the API, of course, is going to be written in a programming language, and the API is going to be hosted in the cloud. So the reason why I said fundamentally you are not generating data with cloud is because the functionality that is going to generate the data is not going to be written. It's going to be written by a human being, and that functionality is going to be hosted in the cloud. So all in all, you are not generating data with the cloud.
Okay, very clear. I hope the person who asked has gotten that answer. Okay, so Tobena, I'm just going to merge like 3 questions together because they're sort of like related. This first part says, does one need to be a software engineer or developer, a Python or Golang developer before starting DevOps engineering career? And then how do you now start that journey? And just adding to that question, do you need certifications like AWS before you can secure a role in DevOps?
Yeah, I love those questions because the last one is something I always like to answer. But then I'll start with the first question, which was around knowledge of Python and Golang before you can start your DevOps career. So with DevOps, right, it's good. It's a good to have. It's good to have knowledge of a programming language. Why? Because it gives you an idea of what you're going to be doing. You're going to be building out, processes for developers to enable developers do their work. So having that knowledge is very, very key as to how quickly you're able to understand their pain points and address them. However, must you? The answer is no. Should you? Yes, that's what I would say. More of what you would be writing is infrastructure as code and automation scripts. So things like knowing how JSON works, YAML, that's more or less what you'll be doing a lot of. You have to write scripts as well that might involve Python. So it's good to know a language at least. And then the second question is how, right? Am I right, Victoria? The second question is, you now start that journey. Okay. So the second question is, the simple answer to it is starting your journey is basically finding, so there are different processes, right? Number one is you can get a course online, right? A course on Udemy, on YouTube for free if you don't want to pay any money, because situation hard right now. I'm joking, don't mind me. But if you don't want to pay, then you can get it on YouTube. They have some really good tutorials on YouTube that will take you through a process of building a project with a programming language. You can also get courses on Udemy, on Udacity. But then we have 3MTT.
Yes.
So we're covering that. 3MTT gives you that, plus the second thing I wanted to say, which is mentorship. That's one of the fastest ways to get into engineering. In fact, that is what I've mentored at least maybe 50 people since I started my career. I can't remember, I can't keep count. But mentorship has been the fastest way I've seen people grow in the field. And then the final question is whether you need a certification. Must you have a certification? I might sound biased right now, but no. Why? I'm telling you from experience, having done this for 12 years now. and having have had people pass through me, having grown through in the industry, I'm still growing even now. I've learned that certification should be more of a validation of your skill as opposed to your skill, making it your skill, making it the thing that you show people to give you a job. Why? You might pass a certification, you can pass a certification from reading and just following dumps online. But then when they give you work to do, you're not able to do it because you don't have real world experience. So what I tell beginners is this: focus on your skill and building your skill in the first maybe 6 months to a year. Just focus on your skill. Then do certifications to validate your skill so that if the certifications give you a foot in the door, you're able to sit down at the table, right? And not get a foot in the, and they turn you back and tell you to go because you can't really do anything that will bring value to the company. So that's what I would say there. Now, I said I might be biased, but it's the experience that I'm talking about.
Absolutely. Thank you for sharing that. Tayo, I just asked you this question. Many learners are coming into cloud computing and they might not have a traditional development background or a science background. What are the key things that they should focus on to start their cloud computing journey?
Okay, thank you. One of the things you can do to start your cloud computing journey, especially on a very good note, is to go to the documentation websites of the vendor. So for instance, you want to learn AWS. You go to AWS documentation website, they have courses that are tailored to beginners. Because the best person that can give you the best course is the vendor of that particular product or that particular technology. So if it's Azure that you want to first learn, go to Azure's documentation website. If it's GCP you want to learn, go to Google Cloud Platform's documentation website. So that's the best place. And also there are, just like Obina mentioned, also mentorship is very, very important. So because there are many resources online. Let me be honest with you. There are many resources online can be very confusing to a beginner. So when you have a mentor, they can guide you on the best pathway to go. So documentation, mentorship, those two are very, very important. Thank you.
Amazing. Just one question for you as well. Can C++ be used in cloud computing?
That's a very old programming language. It's more C++ is more or less like hardware programming.
Okay.
So maybe the person wants to utilize as an IoT, maybe a cloud IoT engineer, something like that. It's okay. But generally speaking, well, I've not come across anyone using C++ and cloud.
Okay. Amazing. Tabena, this is just going to be the final before we take final words from both of you. Somebody's asking, what's the difference really between DevOps engineer and software engineer? And must a DevOps engineer be a software engineer? So it's sort of like confusion between those two.
Oh, okay, nice. So the difference is this. A software engineer is somebody that writes code and builds applications. So, for example, I mean, we all know, Money Point. The software engineer is the guy that wrote the code that built, when you go on there, if you check their websites, sorry, my light just went off. It will probably be back on in case I look like a ghost. But the software engineer is the one that writes the code to build applications. So with the software engineer, you have front-end engineer, you have back-end engineer, you have mobile engineer. Those are the guys that write the code to build the applications. The DevOps engineer writes the processes, code in certain cases, that will ensure that the code that the software engineer has written is fine. It ensures that code is good enough to go into production, which is live, so that people can use it, and ensures that that code that the person wrote is also monitored, so that if there's any problem, they can be proactive. They can roll back to the previous version of the code or, fix it much more easily. Now, this is an oversimplification But software engineer simply is the guy that writes the code that powers the application. The DevOps engineer is the one that writes out the code and the processes to ensure that the code that was written by the software engineer gets to production in the best possible state. So that's the difference between the both of them. Was there another nuance to that question?
So that's very clear. We have more questions coming in. I'll just take two. I hope you don't mind, Tobina and Taiwo. Let's just take two more questions. So someone is asking, does one need to identify a skill in him or herself to know if cloud computing or DevOps is the road to follow? I mean, if I'm just new to tech, how do I know this is the path I should take? Is there a particular skill I must have to choose? And how do I identify these skills?
Okay.
Any of you?
Okay, let me go first. Let me just say, if you're somebody that is analytical, you like to know how things work, you like to solve problems, and you like computers, right? When you see a product, you want to know, how is this thing possible? How are they able to put a card in this POS and then the POS is debiting my account and I'm getting cash? How is all this working? If you're somebody like that, then you already passed the first test to be a software engineer. Now, if you have analytical thinking as well, you can think through situations. You like to solve problems too. There's a problem, you want to solve it, then you can be a software engineer. That's what you need. You don't have to go to and study computer science like me. Most of the people I have mentored, a strong 80% of them did not study computer science. In fact, the best person I have mentored, what she studied was mass comm. And she's working, she's away in Ireland working with Google now. So yeah.
Wow, amazing. Taiwo, do you have anything to add to that? Are there any necessary skills that you need for cloud computing before you start?
In addition to what Obina just said now, in addition to what Obina just said now, in addition to what you just said now, there is no particular skill. I think one of the most important things that you should have is just to be open-minded. Just to be open-minded. And you don't have this mindset. You don't have this fixed mindset that you must have had a background in IT for you to be able to thrive, irrespective of whether DevOps or whether software engineering whatsoever. When you have an open mind and you believe that you can learn anything, you'll be fine.
So we're just going to wrap this up. It's been such an insightful, enlightening session for DevOps and then for cloud computing. So in 30 seconds, please just give us final words, for those who have signed up to take on this learning journey.
Okay, I'll just start. Let me go first because I'm trying to pack up forward. So I'll just say that cloud computing is here to stay for a very, very long time. And more organizations are adopting this technology. And if you want to stay ahead, you must be ready to learn this technology as well. And also to upskill. And just like Mobina just said, don't just focus on the certification. It's really going to damage your reputation. By the time you get a job and you're not able to perform on the job, it's going to damage your reputation. So just focus on learning the skill, knowing how to solve problems with that skill, and from there you'll be fine. Thank you for having me.
Thank you. Sabina, first in 30 seconds.
All right. So just adding to what Taiwo has said already, don't be scared. There's that a lot of information has come at you today. Could I be a software engineer? Should I do DevOps? Should I do cloud? Just relax, take a deep breath. Just I saw Victoria taking one. So just check what you need to, just look at what you want to do and follow it step by step. It's a journey. Don't try not to get overwhelmed. You're not always going to have fantastic days, but have a goal in mind. And the 3MTT program is already here to sort all that out for you. The process is very, so just focus. All right. Thank you.
Thank you so much. So 3MTT Fellows, we've come to the end of this particular session. I do hope it was insightful for you and has empowered you on your journey on cloud computing or DevOps. Until next time, please drop in the comments, say thank you to Taiwo and Tobina for sharing. And until next time, bye for now. Enjoy a productive week. Bye.